Hello everyone, this is Dr. Frank Shea, and in this section I'm going to give you the answers and also how we work through the review questions for for exam 1, for first test, that covers chapters 1 through 4, right? Let's go here. First question, the number of passengers bumped on a particular airline flight is what kind of data? In case you're not familiar with this so-called bumped airline passengers, it means that, when airlines sell tickets to their seats on their flight, they normally overbook or oversell them. Why? Because if they say, let's say they have 100 seats on an airplane, if they sell 100 tickets, sometime, a passenger or two, a few may come to the airport late or don't come at all. And then the airlines will have the flight, departing without a full flight, full house. And then they'll be losing revenue on those empty seats. So what they do is, instead they actually sell more than 100 tickets on a 100-seat airplane. And when they do that, what if, let's say they sell 105 tickets. Now what if all 105 ticket buyers all come to the airport? They got a problem, right? They have to bump somebody out, either by offering them an upgrade or cheaper upgrade to like business class or first class, or offer them a voucher, or give them some incentive to go take on the next flight. So that's what I mean by bumped passengers. So in order to determine what kind of data this is nominal, ordinal, interval, or ratio, we have to use a guideline in the book, or also in my PowerPoint slide. Can the number of bumped take number 0? In other words, is 0 meaningful? In this case, of course 0 is meaningful, because you can have 0 number of passengers bumped. There's no one get bumped, right? Therefore, we know it's a ratio. So the correct answer is D. Second question, which statement is false? The answer is B. But let's say A, random dialing phone service have low response and are poorly targeted. We know that because you just call the numbers on the telephone book or yellow page or white page, and it's poorly targeted, not targeting any specific group. You're randomly calling. And also the response rate is low because nobody wants to answer that. So this is a good correct statement. B, selection bias means that the many respondents dislike the interviewer. That's simply not true, because people do not want to respond because they just don't want to do that, or they have no time to do that, not interested in doing that. Right? So it's not like they don't like the person, the interviewer, the caller. Simple random sampling requires a list of population. That's a true statement. We know that to be the case, because you have to have a list in order to select randomly from the population to get a sample. So this is a correct statement and not correct answer. D, web surveys are economical but suffer from non-response bias. That's also a true statement. So the answer for A, for question number 2, is B. Okay. Next question, number 3. An accounting professor wishing to know how many MBA students will take a summer elective in international accounting did a survey of the class she was teaching. What kind of sample is this? Obviously, for this professor, the class she's teaching is convenient to her, and she can just ask her students to participate. So that is a convenient sample. So D is the correct answer. It's not a simple random sample because there's no random selection process. It's not cluster samples. She's not getting involved in the geographic clusters. It's not a systematic sample because she is not using a systematic sampling technique involved. Okay? Look at number 4. Which display is most likely to reveal association? Right? If you look at all the 4 answers given, dot plots, scatter plot, histogram, and radar chart, A and C and D are all dealing only with one variable. That with one variable you do a dot plot, or a histogram, or radar chart. Right? Scatter plot, however, though, is done or is drawn with 2 variables. You know, we have x, y scatter plot. You have x variable and y variable, and that the chart itself reveals the association between the 2. So scatter plot B is correct answer. Number 5, a line chart will not be suitable to display which data? Right? A line chart. Let's see. U.S. oil imports from OPEC nations for the last 20 years. B, annual compensation of the top 50 CEOs. 3, C, ExxonMobil's quarterly sales data for the last 5 years. And D, daily stock market closing prices for Microsoft for the past month. If you look at all 4 answers, 3 of them show them actually some time series data. And that's exactly what the line chart is suitable for. The annual compensation for top 50 CEOs, B, is not time series data. It's a cross-section data. It's not best suited for line chart. Therefore, B is the correct answer. Right? Number 6, which is not considered a deceptive graphical technique? And the undefined units, of course, we know is deceptive, because you are now showing, you know, the units in the chart. 2D graphs, this is normal. You know, most of the graphs we give, what we do, are 2D, 2-dimensionals. Right? And 3D graph could be deceptive, right? As we have seen, we have talked about it in class or in my lecture. So 2D graph would be is the correct answer, because it's not deceptive. Authority figures could be deceptive, as we said. You know, you're assuming someone with the status to tell a story. Right? That could be deceptive. Distracting pictures, of course, is also deceptive. Could be deceptive. So D for number 6, B is answered. Number 7, the distribution pictured below is what? We can see A is bimodal and skewed right. We can see that there are 2 peaks here, one here and one here. Right? That's bimodal. Is it skewed to the right? Yes, it is. The tail, the long tail, is on the right, therefore is skewed to the right. So A is correct answer. B is wrong because it says bimodal, but it says skewed left, which is not the case. Skewed right is correct, but is not the best answer. And skewed left, of course, is wrong. So in our test, be careful. You choose the best answer, correct and best answer, and the C is correct, but it's not the best. It's not telling anything about the mode. Okay. Number 8, Bob found an error in the following frequency distribution. What is it? Right. This is the distribution, frequency distribution, and the classes, model classes. Right. What's wrong with it? A, the classes are not mutually exclusive. Well, let's look at that. Was 1 to 10 is one class, 11 to 20, 25 to 30, 31 to 40, 44 to 50. They are mutually exclusive. There's no overlap between the classes, right? But B, the classes are not collectively exhaustive. Is that right? Yes, that actually is the correct answer, because they're not exhaustive. We can see that what if the number is between, say, 20 and 25? Let's say the number is 21, 22, 23, or 24. It's not in any one of the categories, 2 categories, so it's not covering all the possibilities. So it's not exhaustive, even collectively. there are two field class intervals. That's according to Sturges law, right? And the first class should start at 0. Now you don't have to start at 0. Okay, so B is the correct answer. Okay. Number 9. If you have 32 data points, how many classes would Sturges rule suggest? If you look at Sturges rule, okay, let's see. Go to the page. And this is the Sturges rule. If you can see, right, this Sturges rule for 32 sample size of 32. What do we see? Yeah, we should indeed have 6 classes. Okay, so let's go back. According to the, if you have 32 data points, you should indeed have 6. So B is the correct answer. Okay. Now let's go to question number 10. Let's look at question number 10. Which of the following is not a valid description of an outlier? A data value beyond the outer fences. We know that is outlier, right? So therefore it's not a good answer. A data value that is very unusual. So this statement is kind of vague, but it's description of the outlier. So it's not a good answer. A data value that lies below Q1 and above Q3, the below Q1, the first quartile, above the third quartile, and that is not a description of outlier, because it's just outside, just below Q1 or just above Q3, it still is not very unusual. And D, so that is the correct answer. C is the answer. D, a data value several standard deviations from the mean. And now we know if several standard deviations is more than 3, more than 2, we call that an outlier. Okay. So question number 10. Now let's look at question number 11. In a sample of 10,000 observations from a normal population, how many would you expect to lie beyond the 3 standard deviation of the mean? Right? Now, how do we solve the problem? Let's look at the empirical rule here. If you remember the empirical rule, it says, right here, within 3 standard deviations, from here to here, you should have 99.73% of the observations. 99.73%, right? Let's go back to the question. If you have the 99. Let's do some quick math here. If you have, if you have 10,000 observations, and move the frame back here. You have 10,000 observations, right? And how many should lie within 3 standard deviations? We know it's 99.73. So 10,000 times 99.73, you get what? 99.73%, you get 9,973. That's within the 3 standard deviation. Then what is outside of the 3 standard deviation then? It's 10,000 minus that point, 9,973. That gives you about 27. So therefore, B is the correct answer. Okay? Let's go to question number 12. Okay. Exam scores in a small class were 10, 10, 20, 40, 60, 80, 90, 100, 100. For this data set, which statement is incorrect concerning dispersion and shape. And for this one, actually the correct answer is B. The data are left skewed due to outliers. You can see they will have more values more scored to the left, to the lower side, left side. Therefore, we say it's left skewed. And the coefficient of correlation is 65%. You can calculate that. You find that not to be the case. And the mid-range and mean are almost the same. That's not true either. The third quartile is approximately 90. That is true also. Okay. That's number 12. Number 13. I think that's the last question. Yes, last question. Okay, for question number 13, 12 randomly chosen students were asked how many times they had a missed class during a certain semester. With this results right here, how many times? The standard deviation is what? Right? For this one, I'm going to solve this problem using Excel. Okay, let's move on to an Excel spreadsheet. This is what I have here. Okay, 3, 2, 1, 2, 1, 5, 9, 1, 2, 3, 3, 10. That's the original data. I put them in a column like this. Okay, we call that xi for the data value itself. Okay, and then this column, let me delete that first. Okay. This column we're going to define that as xi minus mean. Now, what is the mean of this column? In here, we redo that. We type equal average. Type average, and then give the range. And from this to here, that's everything, all the data here, points we have, right? If you use average, that gives you 3.5. And in this cell here, we use that to to denote xi minus mean. That is equals xi is this one first data set minus the mean is 3.5. We just calculated at the bottom right here. So this cell here is a JA, which is this cell here minus 3.5. You hit enter, they give you minus 0.05. Because this is 3 minus 3.5, you should get minus 0.5. Right? And I'm going to copy this down. Then we will have calculated all the xi minus its mean. Right? And then for standard deviation, we need to calculate the xi minus the mu squared. Right? So for squared, we just use this column, the cell, multiplied by itself. Ka times Ka again. Right? That gives you the squared value. And then we're going to copy this all the way down. That's squared. Let me delete that and redo that. Okay? So this is the xi minus mu squared. Right? And then we know by the definition of standard deviation, we need to add them up. So we can add them up equals sum, parentheses, we will include all this in the parentheses. Then they give you the sum of 1.1. And also from the definition of standard deviation, next we need to do is we need to find, use the sum of the squared difference. We need to divide that by the total number of samples, n minus 1. In this case, n equals, let me redo that. Okay. That equals this one divided by, since we have a total 12 sample observations, 12 minus 1 is 11. So it's L20, this cell here divided by 11, that give you 9.18. And then, so then we need to find the square root of that to get standard deviation. The square root of this case, we'll type equal SQRT, the square root, right? And this, put the cell here. We hit enter, give us 3.03. Now, what is this? This is the standard deviation. Okay. Now let's go back to the question. 3.03. We found the B to be the correct answer. Okay. Of course, you can use the Excel spreadsheet to do that, and you should be able to use hand or a small simple calculator to do that as well, or you can choose Excel to do that. Okay, and that concludes our that's all the answers for all the review questions for your test 1.